Hi, I wanted to show you where I'm at currently with the ventilator design with the piston pump idea. So I wanted to show you the physical embodiment of what I've shown you before in the CAD. So the piston pump is of course this thing right over here. You can see the motor with the rack here, which is inverted. So the teeth are pointing downwards and the gear is down below here. And then when we look at the other side, we have the output to the patient with the one-way valve, and we have the other one-way valve, which is the intake into the piston. So let me turn on the power on this thing and you can see roughly how this is supposed to go. The other two things that I want to mention real quick here are this little box here. This little box is essentially a 3D printed box that has been glued shut, and this holds one of the pressure sensors in the system. And this bit over here is the exhaust solenoid valve, which allows the patient to exhale. And when it closes, it ensures that the air doesn't leave here, but that it is forced into the patient instead. This currently doesn't work because the piston isn't developing enough pressure, and I'll show you that in just a minute. So taking a look now at the interface, this here would be the software that you'd use. So you can see the pressure reading here, which later would hopefully be a graph instead. This is the position of the piston, and then here would be all of the settings that you need to put in. And the problem that you can see now is that even though the machine is turtling away, the pressure inside this glove here, which is the test lung in a way, won't rise above this 4 centimeters of water. So there is so much leakage inside the piston and so much friction at the same time that I can't really develop enough pressure to really make this thing work. So the steps here are still going on, but I've turned down the power now to quiet everything down a little bit. And you can see the pressure decreasing slowly because of some leaks in the system. I don't think this is really significant, but the main problem is that the piston simply isn't developing enough pressure. The final thing I want to show you is the circuitry. So here we have the input of 24 volts. We've got a big stabilizing capacitor down here. We have one pressure sensor here. This is reading the ambient pressure, and this lead over here goes to the other sensor which was inside that little box, and otherwise it's exactly the same sensor as this one. There is a 5-volt converter here with the output terminals here, and that is for powering the Pi, but currently the Pi is running on its own micro USB power. We have 4 leads here for the stepper motor. And then here we have the driver for that motor. Now I went to 24 volts because that gives my stepper motor much better power. It allows it to go much faster and allows it to have more torque at such higher speed. But I have a 12 volt solenoid valve, so here is a 12 volt linear regulator with appropriate large heatsink. And then here there is a little MOSFET switch circuitry with a little opto isolator there, and that allows me to trigger the 12 volt into the solenoid valve via this MOSFET and the 12 volt coming from the regulator. So there's not very much to it. I'd say it's quite an easy circuit, even I can build it, but that's what it is.